the output reading of the measured device. So we are going to have two stages in measuring device will be there. So the measurement is felt as a sensor, and the measured signal is transformed or the converted into the form of sensor input what we have. Okay, we have to note these two important notes are going to be important. Typically, sensor senses the measurement and automatically converts into a sensor or output, whereas the term sensor and transducers are used interchangeable to denote the sensor and transducer unit what we have. So here the main purpose of this particular sensor is going to be convert the measurand. Okay, that is what is the parameter which you are going to be measured that will be transmitted into an measured value what we have. That is the major purpose of this particular sensor. Okay, so my voice is not clear. Hello.
Sir, it's audible, sir. Clear, sir.
Audible and hello.
Sir, audible, sir.
Audible. Okay. Then we are going to be we will able to go further. So we will able to see what is the definition for the sensor. The sensor measures unknown signal and parameters of a plant and its environment. Okay, this is going to be the definition what we're going to have. So we will able to discuss about what are the different main uses of the sensors what we're going to have. At the same time, we are also able to discuss about the multiple sensor fusion also we're going to be discussing. That is going to be one of the advanced topic what we're going to be having in industry 4.0. That also I will able to discuss for that one. Okay, so these are some of the typical sensors and actuators which are going to be mainly used in your automobile industry. So what are the different sensors and actuators which are going to be used in the aircraft industry? What are the different sensors we are going to be using? What are the different actuators which are going to be using in this particular aircraft industry? Similarly, this automobile industry, this is going to be one of the important present trend where we can have different sensors. And home heating, milling machines are the machine tools, the CNC machines, CNC machines which are going to be used, and these robots. I will able to discuss in detail about in this session. We will able to mainly discussing what are the main sensors which are going to be required for this particular robot. Everything I will able to discuss in a detailed manner. At the same time, I will able to give you some brief idea on what are the different sensors which are going to be required for this particular automobile industry. Also, I can able to discuss more in detailed cases what going to happen. Okay, so in the automobile, the main sensors which are going to be used are the powertrains, that is the engine and transmission systems. So which are and the samely driving aids like ABS cameras. This is going to be, and the safety and comfort things sensors also will be there. So we are going to be having the automobile sensors. We are going to have these main classification are going to be there. I will able to discuss about all these things, how we can able to have the safety and comfort sensors. We are going to be having the MEMS based sensors which are going to be used in the safety and comfort area of this particular automobile engineering. At the same time, for autonomous driving of the vehicles, we need some autonomous sensors also will going to be required. That also I will able to discuss you. And these powertrains now presently the automobiles which are going to be presently, we are going to be having IC engine based. Now these engines are now converted into from the hybrid vehicles or electrical vehicles. They are going to be changing to hybrid or electrical vehicles. So in that case, we need some different powertrains are going to be required. We will able to see what are the different the powertrains which are going to be required for this particular case. Okay, so this is why we need what are in the use of in case of in the case of control system, we will have the main purpose of this thing is measuring some type of systems inputs. Okay, for feed forward control. So measuring output signals for the system monitoring. Okay, self-tuning. These are all some of the important things which are going to be discussed in the next session. What are the different sensors which are going to be required for control system and the measuring of input pairing is all they will be there. Okay. So now we will able to discuss. We will able to compare the sensory human system. Okay, what are the human being which is going to be having the sensory organs and how this particular sensory system can be replicated or we can able to mimic in any particular robotics or the automation what would help. So as a human, we are having the five senses are there: the sense of vision, the sight, okay, hearing, that is audibility, and the touch, that is the tactile, smell, and taste. So these are going to be the different five senses which we are going to be which we are going to be having that beep sound will come whenever someone is joining. That is not my problem. That is software problem. I cannot help. Okay, so these are all some five senses which are going to be there, and these five senses which we can able to use for the cases. But if you are considering this robotics point of view, the first three senses, that is vision. Okay, how you can able to visualize that particular thing, and how you can able to hear, and how you can able to touch. So these are the three important sensors which are going to be there for the robotics. If you want to have the intelligent robotic systems, these three things are going to be there. We can able to have the visionary by using some cameras. We are going to hear by using some microphones, and we are having some tactile sensors which we can able to have. But the intelligent robots cannot able to have the smell and taste tests we are not able to have. But the humans is going to be having these other than these five senses. They also have other type of sensory features like sense of balancing, pressure, temperature, pain, motion, etc. We are going to be having some of other features also will be there. Okay, so these are all the different the sensory systems which the human beings are going to be there. And if you see in a broad classification, the vision, hearing, the tactile sensors and smelling, that one in the human system, it will be able to make one stimulus is going to be generated. That is going to be a stimulus, means it is going to be a signal, and that stimulus signal will be sent to this particular central neural system, and corresponding central neural system will be able to give the command or action potential that will able to make the neurons activate of the particular system. The same thing also we can able to have in your the sensor and activator systems. Also we can able to have different sensors and transistors will be there, and we will able to have some different communication will be there, and the signal processing also will be there in your sensor systems what we have. So these are all some of the human sensors which are going to be available. The neurons are what we're going to have. So now we will able to see what are the basic sensor classification. The basic sensor classification will be based on the physical and physics and technology. We are having active and active. So power for sensing. That is the from this particular we need the powering should be done from the external sensors. From external source we have to get the powering. Okay, so we are having analog and digital sensors. The output of the sensor is going to be analog, and digital sensors means we are able to get the digital output from zeros and ones. We are having a passive sensors where we can able to have the power is going to be generated by themselves only. Okay, and we are having a piezoelectric, piezoresistive, and elastic. These are some of other sensors which are going to be there. Okay, so mainly the other classification, the broad classification is going to be mainly depending upon the resistivity, capacitivity, and inductivity. Okay, so whatever the sensors available in the market, the 75% of this particular sensors are going to be based on this type of these type of physics technologies which are going to be there. So there will be the principle they are going to be using either resistivity or capacitivity. That is, it will also includes the piezoelectric and inductivity. It also includes the magnetic also you can able to have. So 70% of this particular sensors which are going to be available in the market are based on this particular principle only. Okay, so So then we are having further classification based on the measurement application, like biomedical sensors are there, chemical sensors are there, and electrical electronic sensors are there. This is another classification where we can able to have. Okay. Similarly, mechanical and thermofluidic sensors also will be there. So this is one of the important slide how you can able to select a particular sensor for your application. Okay. So first, what you have to do is you have to study the application, its purpose, what quantities needed to be measured. So what quantities needed to be measured, that is going to be the first step we have to make. So determine what sensors are available, what quantities cannot be measured due to inaccuracy or the lack of sensor. That also we have to, it is also will be used. Okay. So match the sensor with the required specifications. Match the sensor with the required specifications. You can able to do that one. Okay. So this is how we can able to make the sensors which are going to be using that one. Okay. So just people are telling it is beep sound is coming up. 1 minute. Just I will change my. Okay. So now I think we will able to that sound it is decreased or what we will able to see. Okay, is my screen visible, Anuj?
No, sir.
Yeah. Okay. So then we will able to discuss. We have seen that particular what are the different how we can able to select this particular sensor here, and if it cannot measure, then estimate using the quantity that can be measured. Also, you can able to see that one. Okay. So, or you can able to develop a new sensor for your purpose with the parameters that meet the requirement specifications. That is how you can able to select the particular sensors what we have. Okay. So sensors means the selection is going to be the matching a sensor. It's the
Sir, your
rating
screen
to
is
the.
not visible.
Hello.
Your screen is not visible.
My screen is not visible. Okay.
Yes, sir. Now it's
Oh,
visible, sir. Please
yeah.
continue.
Okay. I have given permission. My that host have changed. Okay. 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 Now it is visible. Audio. Okay.
Yes, sir. Yes, sir. It's fine.
So, the main, the overall thing, what the overall, so sensor selection is going to be the matching of this particular sensor rating. Uh, so still it is coming, no problem. That I cannot help. The beep sound will leave it. Okay. So the overall process is going to be matching the sensor to its application requirements. What going to have. Okay. So next we will be able to see what are the different the sensor characteristics which are going to be there. One of the important characteristics we have to consider this one is the fast response. Okay. So the output of the measuring devices instantly reaches the measured value. That is going to be called as a fast response. How fast the sensor is going to be there. Okay. So next important thing is high gain, low output impedance, and high sensitivity. This is going to be another important characteristic of the sensor. It's going to be considered. Okay. So the next important is the stability and robustness. Okay. The stability and robustness. The stability and robustness means the device output remain at the measured value unless the method itself changes. So it is going to be it cannot able to affect the different noises and disturbances. That is going to be called as stability and robustness. What we have. Okay. So next is the static error. The static linearity. Once you are going to be getting the relationship between input and output, we are going to be getting the linear relationship. Then it is going to be the best sensor what we're going to have. At the same time, it should have high input impedance should be there. That means if you are having high input impedance, the power consumption is going to be very, very less. The sensor power consumption is going to be less. So the sensors will be able to have the high input impedance is going to be there. Okay. So these are all some of the important, the perfect sensor characteristics which you are going to be having. It should have a fast response. It should have a high gain. Low output impedance and high sensitivity, stability and robustness, static linearity, and high input impedance. What could have? Okay, so these are some of the important commercial available sensors which are going to be there. We are having some potentiometers which are mainly used for linear and rotary motion. We are having some piezoelectric accelerometers. We are having LPDTs, thermocouples, and the tachometers are what we have. Okay, so now we will able to I will able to discuss in detail what are the different sensors and activators which are going to be required for a robotic system, so that it will be easy for you. I am taking this case study as the robot system. So I am taking a case study of the robot system and what are the different sensors. What are the different sensors and activators are going to be required for this particular robot system? I can able to discuss with you. Okay, so here, if you consider any particular robotic system, we will able to have the robot arm will be there, and we will able to give the program commands will be given to this particular robot, and that particular robot will able to do some actions on the environment what we have. So it will be a pick and place robot or anything robot what we have. That actions will be done for fun. Okay, so this particular robot will have some mechanical units will be there, and sensing unit will be there, and the activating unit will be there, and the supervising unit will be there. This supervising unit will be considered as the control system what we're going to be having. Okay, so now we'll able to discuss all in detail what are the different sensors are going to be required, and what are the different activities are going to be required if you want to have a particular robot system has to be done. Okay, so the mechanical units what we're going to be considered is the robot arms. Okay, it may be a as you know that the robot is going to be made up of different links and the joints will be there. So we are having either rotary links, or we are going to be having either prismatic links will be there. So we are going to be having some prismatic links or the rotary joint links which is going to be there. That all will be considered as the mechanical units what going to have. Okay, so to get this particular rotary links or the prismatic motion, we need some different types of actuators like electric motors are going to be used there to get the exact the rotation of this particular link. Okay. Okay, and we are having the different sensor units will be there, and these sensor units are mainly classified into two categories. One is internal robot sensor, that is prospective and extrospective are the different. That is internal and external world sensors for going to have. So what are the different sensors which are going to be used inside the system, the sensor system? That is called the prospective sensors, and extrospective sensors means external world. The sensors which are going to be contacting with the external environment, that is going to be called as the external world sensors for going to have. Okay, so now in the coming class we will able to see what are the different types of the prospective sensors or the internal sensors, and we will able to discuss what are the external sensors which are going to be using. Okay, so next we are going to be having the activating unit, which is going to be consists of different motors. That motors may be either electrical, hydraulic, and pneumatic activators will be there, and motor control algorithms we are going to be mainly used from. Okay, and the supervising units will able to contain the task planning control and artificial intelligence, and that is also will come from that. This is the supervising unit will mainly consist of the microcontroller or the processing, which will able to mainly use it for the track planning of this particular robot arm what we have. Suppose if you want to pick this particular object, this has to go this arm, this end effector has to reach this particular point. Okay, so for that case we have to design a particular path planning is going to be done, and if any particular obstacles are going to be there in this particular part, it has to overcome that one. That all will be done by using this particular supervised units what we have. Okay, so coming to this particular the activation system in the robotic system, we will have these are the important components which are going to be there in this particular activation units. Okay, so we will have the total a power supply will be there, so we can able to have the power supply, and that particular power amplification is going to be done, and that will be feed to this particular the servo motor, and this particular servo motor will able to give two different the transmission elements like the gear trains which are going to be used, or the belt trains. Through this particular belt trains and gear trains, this particular activator transmits the power to the particular mechanical systems what we have. That is how the total activating systems which is going to be there in the robotics what we have. Okay, so now we will able to see what are the different the activators which are going to be used, the purpose of this particular activator. So the main purpose of this particular activators is the actuator So the activator mechanical drives or moves that one. Okay, we will have the two different categories of activators are going to be there. One is incremental activators and continuous activators will be there. Okay, so coming to this particular incremental activators means moves in a incremental steps. So the movement of this particular activator will be in the if you are going to be considering this activator will be considered as either linear motion or rotary motion. So we can able to have either linear motion or rotary motion. The linear motion means x, y, z movement. The rotary motion means theta movement. Okay, so if these linear incremental activators can able to give the movement, the incremental activators will able to have a movement of steps wise. So it will able to have a small stepwise, and the continuous activators will able to have a continuous movement will be there. Okay, so we will able to discuss what are the different incremental drive activators and continuous drive activators which are mainly used in this particular robotics. Okay, so the incremental activators which are mainly used is the stepper motors. Okay, this is the stepper motors are mainly used for the incremental activators what going to have. So for the continuous activators, we are going to be having three different types. Two different types are there. Mainly three different. So these are all comes under the electrical activators, and we are having pneumatic and hydraulic activators are there. In the electrical activators, we are going to be having DC motors and AC motors are there, and the DC motors we are having brushed and brushless DC motors, and in AC motors we are going to be having induction motor and synchronous motors are going to be mainly used at that one. Okay, so these two is going to be considered as the electrical activators. Okay, so these are going to be considered as the electrical activators, which you can able to give a continuous motion will be given for this pump. Okay, similarly, if you want to have this, mainly these electrical activators are mainly used for the rotary motion. If you want to have the rotary motion, these electrical activators are mainly used. If you want to have the linear motion, then these hydraulic and pneumatic activators are mainly used to get the exact motion. Okay, so in this particular stepper motors, once again, these stepper motors are further classified as permanent magnet stepper motor. Okay, and variable reluctance stepper motor. So in this, the main difference is we are having a magnetized rotor will be there, and whereas here the ferromagnetic rotor will be there. Okay, and then we are having a hybrid stepper motors also will be coming in the market, and this will be having that two pole. This is going to be the overall classification of stepper motors is going to be this one. Okay, so I did not deal with the more detailed of the working principles of this particular thing because it will take another 1 hour for me to explain all these things. Just I will able to give you a basic look for you, so that these are some of the activators, the working principles you can able to study for you. As you know that this course will be, I used to teach this particular course for total 6 months. That is one semester course. This one, if I will start this one, I cannot able to cover all the things in this particular 2 hours. So just I will able to give you some insight on you, so that you can able to have the details, you can able to learn by yourself what going to happen. Okay, so coming to this particular the continuous the drive activators, we are going to be having the DC motors and AC motors, that is a brushed and brushless things are there, and hydraulic and pneumatic actuators will be there. Okay, so this DC motors, as you know, this is going to be the working principle. Just I will skip this one. You know that one. Okay, so in this particular DC motor, we are having the brushed one and brushless one. Where in this particular brushed means we are having the slip gauges will be there, and in the brushless the slip gauges will not be there. That is the main difference. We can able to have thing. So the main important thing is when you are going to be using the the brushless things, the smooth movement can be there, and the speed controllers also will be there, which is going to be discussed. Okay, so coming to this particular AC motors, we are having inductive motors and synchronous motors are going to be mainly used there. So this AC motors are going to be the cost effective what going to have. That is one of the important thing we are going to have, and they are having less head orders. So there is since in the DC motors we are having the spark will be there. So the brushes, brush and brushless, we can able to get some electrical spark will be generated. That will be hazardous because you cannot able to use this type of actuators in the chemical environment or food processing unit. We cannot able to use, but they are going to be cheaper cost. Okay, so that's why they can able to use that one. And these AC motors are also another important thing is they are heavy duty. Okay, they are going to be heavy duty. If you want to use in the rolling mills or presses, a big machinery, if you want to have, then you have to go for the AC motors only, and the continuous motion will be generated, and the household applications and industry, they are going to be mainly use this particular AC motors are mainly use that one. Okay, so we are having inductor motors, the working principle, just I will skip it. So we are having synchronous motors also. So this is also these are the main important two different types of the continuous actuators which are going to be there. Now we are going to be having this hydraulic actuators. This is going to be another important thing where we can able to use two are things. We are having the hydraulic and pneumatic actuators are there. Okay, so these hydraulic actuators are mainly used. The working oil is going to be used as the working fluid. Okay, the oil is going to be mainly used as the working fluid. If you are going to be using the air is going to be used as the working fluid, then it is going to be called as the pneumatic actuators. What going to have? Okay, so the same principles which are going to be used. The only difference is the working fluid in the hydraulic actuator is going to be the oil is going to be used as the oil is going to be used as the working fluid, whereas in the pneumatic we are going to be using the air is going to be used as the working fluid. Another important thing is these hydraulic actuators can able to be used if you want to have higher loads, if you want to generate higher force, then you have to go for this particular hydraulic actuators. So suppose if you are going to be using the JCBs, when you are going to be using the JCBs where the hydraulic actuators are mainly used, when you are going to be using the lesser forces like opening of the Volvo bus doors like that, then you are going to be using the pneumatic actuators are mainly used that one. Okay, so this hydraulic system will going to contain, this is going to be the basic structure we are going to have. We will have one oil reservoir will be there, and we are having one oil filter will be there, and we need one hydraulic pump is going to be there. We are going to be having some different types of pumps are there, like gear pumps, wall pumps, and internal external gear pumps, and vane pumps are there. Different types of pumps are going to be used there. Depending upon your application, we have to select that particular hydraulic pumps as going to be selected that one. And these pumps are going to be connected to different the pressure relief valve, and different valves will be connected, and finally it is going to be connected the single acting cylinder or double acting cylinder that will able to push this particular thing. Okay, so this is going to be the same thing, and the oil is going to be recollected back, and this oil will be reused for the continuous process. Okay, whereas in the pneumatic system we are not able to have this particular oil reservoir will not be there. we are going to be having one air compressor will be there. So we are going to be having one air compressor will be there, and this compressed air will be used at a very high pressure, some 10 bar. We can able to have some 10 bar pressure we can have, and that air compressor is going to be used as the working fluid in this particular application. Okay, so minute. Yeah. So if you see here, so this is going to be some of the circuit which we can able to have in the, if I want to have this type of application, we need one as I explained you, we need one motor, and this is going to be some reservoir oil will be there, and when this particular pressure is going to be reached, this cylinder will able to break. Okay, so we need one pressure relieving valve is going to be required. So we need this is going to be considered as the pressure relieving valve. The pressure relief valve. This is going to be the pressure relief valve, which will be designed to a maximum pressure. Okay, when this particular pressure is going to be reached to a maximum pressure, automatically the oil, instead of going this side to the activator, it will able to go back to this particular reservoir, so that it cannot damage this particular cylinder. Okay, so next we are going to be having one directional control valve also will be required. So this is going to be the direction control valve. If I want to move this particular actuator in this particular direction or in this particular direction, I want to change this particular direction control valve, and I can, by changing this particular direction control valve, I can able to move this particular activator this side or that. This is going to be called as the direction control valve what we're going to have. So we are going to have the direction control valves like the 4x3 control valve or 5x2 control valve or 5x3 control valve, like this will be there. That the 5 indicates the number of output and input ports, and this 3 indicates the number of portions. Suppose we are going to be taking this is the direction control valve. We are going to be taking we are going to be having 2 positions are there. This is position 1 and position 2, and we are how many inputs and outputs are going to be there, that will able to indicate the top one. So this is, if you are going to be having this 4 indicates 4 inputs, outputs are there, and 3 indicates that 3 portions are going to be there. So we are going to be having 3 portions are there. Okay, so like that we are having different direction control valves will be there, and these positions, the position 1, position 2, and position 3 can be generated by using this particular solenoid valve actions. If this particular solenoid valve is going to be activated, this portion is going to be activated. If this particular solenoid valve is going to be activated, this portion is going to be the activated valve going to have. Okay, so this is another important type of direction control valve is going to be required. Then we need a particular flow control valve also will be required for this one. So this is going to be used for the flow control valve. If you want to move this particular actuator at a slow speed, if I want to move this particular actuator at a slow speed, then we need one slow flow control valve also will be required for this one. Okay, so and we need one oil filter, because this same oil is going to be reused continuously. This oil filter will able to eliminate all the contaminants and whatever the air bubbles which are going to be present in this particular oil, that will be eliminated by this particular oil filter. That's why we need this particular thing. Okay, so this is going to be the overall the components which are going to be required for a particular hydraulic system or pneumatic system what going to have. The same thing will be there in the pneumatic system also, but instead of this particular the oil reservoir, we are going to be having one air compressor is going to be there, and this motor will not be there in the in the in the pneumatic portion what going to have. Okay, so this we can able to represent this in a schematic form. These are all a basic symbols are going to be used, and this is going to be the schematic representation of the exact the circuit. This is going to be called as the hydraulic circuit design. So we, whenever whatever the application we are going to be using, first we have to design this particular hydraulic circuit or the pneumatic circuit has to be designed by using these particular symbols, and once what are the different control valves which are going to be required, what are the different pressure valves required, what are the different flow control valves are going to be required for your application. You have to decide, and then you have to specify what are the different pressures and what are the different flow rates for this particular hydraulic circuit is going to be there. Okay, so we are going to be having one software called Automation Studio. Okay, we are going to be having one software called Automation Studio. Is going to be one software where we can able to use where we can able to draw this particular hydraulic and pneumatic circuits, and we can able to simulate for different applications of this particular thing. Okay, so all your JCBs, everything will able to have some hydraulic and pneumatic controllers is going to be there. Okay, so in your automation companies also, this hydraulic and pneumatic actuating circuits also will be there. First, we have to design this particular hydraulic and pneumatic actuator circuit, and accordingly, you have to use this particular we have to use this particular applications. Okay. Uh, so so this is going to be the different types of pumps which are going to be used here. So vane pumps, gear pumps, and the piston pumps are the different pumps which are mainly used in this particular hydraulic circuits, and the direction control valve. And this direction control valve, as I explained you previously, we are going to be using either solenoid operated or spring operated. We are having some different push button operated, hand lever operated, foot pedal operated, mechanical operated, like that. We are having different types of activating mechanisms will be there, and that will be used for the activation of this particular direction control valve. Okay, so the main, as I explained you, we are going to be having two portions are there. In this, you can able to see this is going to be portion one and this is going to be the portion two. We are having one spool will be there. This is going to be called the spool. Okay, and this spool is going to be moved. This is going to be called as the spool. This spool is going to be close this particular portion, and this has been opened this particular portion. So the oil is going to be coming from this particular case like this. Okay, when this particular spool is going to be moved this side, this portion has been closed. So this portion has been closed and this portion has been opened like that. Okay, so then this will be indicates that this is one position one, and this is going to be considered as the position two. Okay, so that is when we can able to activate this position or this position, so that depending upon your application, you can able to make this particular spool to move. The direction control is going to be working principle is going to be looks like this. Okay, so then we are having the different this is the wall design mechanism. So this I will able to skip for your time being. Okay, so we are having this is going to be the hydraulic cylinder will be like this. We are having the cylinder. These are different components which are going to be there. We can have a single acting cylinder or a multi-actable cylinder. What going to have? So whenever this oil is going to be passed into this one, this will able to move this particular hydraulic cylinder to move forward or backward direction depending upon the case. Okay, so we are having different types of the single activator, the double activator cylinders, and the telescopic cylinders are going to be used in your the hydraulic activator cylinders which are going to be there. Okay, so this is a brief about the hydraulic activators, and the electrical activators are in the electrical activators are mainly used for the rotary motion. In that we are going to be having incremental type like stepper motors, and we are having a continuous type which are going to be the DC motors and AC motors. And in the DC motors we are going to be having the brushed and brushless, and in the AC motors we are going to be having the induction motors and the synchronous motors are mainly used for your applications what going to be having. Okay, so these are all some of this table will able to give you the brief the differences between what are the different hydraulic activators and what are the different pneumatic activators and electrical activators which are going to be used main applications what going to have. So here I already explained you what are the main differences. You can able to make that one. Okay, so once you got this particular hydraulic activators, now you have to transfer this particular torque from this particular electrical activator to the link, the mechanical link. Suppose you are going to be having the robot arm is going to be like this. Suppose we are going to be having this is going to be the robot, and we are having one arm. This is going to be one link, and this is going to be another link like this, and this is going to be the third link like that. Okay, so each link will joint will able to have one the motors or the actuators will be there, and this actuator will able to generate some torque, and that a torque has to be transmitted to this particular link. This is going to be the rigid mechanical link, so that this link can able to move the XY position to get a particular grasp the particular the task what we're going to be having. Okay, so for that case, we need some motion transmission gears as going to be required for this one. Okay, so why we need this thing is the main purpose of this particular motion transmission gears is to transmit low torque high velocity to high torque low velocity. That is the main purpose of this particular thing. You want to convert the low torque high velocity to high torque low velocity is going to be mainly used for this particular application. Okay. So these are all some of the important the transmissions which are going to be mainly used in the robotic systems. So we are having the spur gears will be there, but the main problem is the deformation and the backlash error is going to be main problem. What we're going to be having, we are having some lead spools and warm gears also will be there, and the main drawback will be the backlash error, and the friction is going to be one of the important problem. And the tooth belts, the chain belts are also can be used for the transmission like this, the transmission of the torque from the motors to this particular case. And to overcome the problems what we're going to be facing in this particular spur gears, lead spools and belts, we are going to be having this new type of drives called as the harmonic drives what we're going to be having. So these harmonic drives are going to be mainly used in your recent developed the motor the robots, so which can able to eliminate the backlash error. Okay, so the backlash error means suppose we are going to be having the gear will able to have this is going to be one teeth will be there and another teeth of the gear is going to be there like this. Okay, if we are going to be getting a wear is going to be occurring between these teeth, this we are going to be getting one gap is going to be there. Okay, so we are going to be getting this is one teeth of the one gear and another teeth of this particular gear is another teeth will be coming and matching like this. Okay, if you are getting a wear on that one, this teeth will have one gap will be there. Because of this, we can able to get one backlash error and the accurate position. Suppose if you want to go for the X and Y movement, the torque is going to be required for that one is going to be some 10 torque is going to be required, but it can able to give you only some 9 torque what going to have. Then some errors what you will be having. Okay, so to overcome that particular thing, these harmonic drives are mainly used, which will able to contain one elastic three components will be there. So this is going to be the bearing will be there, and we are having this is going to be the flexible internal gear will be there. So this gear what we're going to be using is the flexible internal gear, and this will I will show you one video. There you can able to understand in a that in a more detailed manner what going to happen. Okay, so so up to now it is clear. So up to now one questions what we're going to okay. So questions, okay. The servo motors, the functioning servo motors, so you can able to see. So the temperature sensors, MEMS will come. Okay, no problem. You have to wait for another half an hour to get your own hero. Okay, so so then we will able to go further. So just 1 minute. Yeah. So we are having these are the some of the transmission gears. So this is different transmission gears what we're going to be having. So this is going to be called as the harmonic drive system. So here, if you see in this particular animation, this is going to be the wheel. One wheel we are having, and this red color one what we're going to be having. This is going to be made up of the fiber. Okay, it is not made up of this. The outer, but the blue color one is going to be made up of the metal, and this red color one is going to be made up of the fiber. And that particular fiber is going to be pressed by this particular rotor, which is going to be there. Okay, so whenever this particular rotor will able to press this particular link, the backlash error will not be there. So this teeth, what I have told you, because of the warming up, we are going to be getting some backlash error is going to be coming. So since this particular green color one is pushing this particular teeth, this backlash and this red color is going to be a flexible teeth. It will able to, suppose if you are having a little gap is there, automatically by using this particular pressure, it is going to be pressing the particular case what going to have. Okay, so you can able to see this in this particular animation. So where this particular the harmonic drives will be used.
Element of the harmonic drive principle used in our gearboxes and servo actuators. Harmonic drive component sets consist of only 3 precision components: wave generator, flex spline, and circular spline. The wave generator is the driven element of the transmission. The ellipse-shaped form of the wave generator is fitted with a specially designed ball bearing. The flex spline is a high-strength, torsionally stiff yet flexible component with external teeth, which reliably transmits high loads. The circular spline is designed as a rigid ring with internal teeth. The circular spline has 2 teeth more than that of flex spline. By inserting the wave generator into the flex spline assumes the elliptical shape of the wave generator. The rotating wave generator causes the flex spline to radially deform. The assembled gear has 2 diametrically opposed tooth engagement areas around the major axis of the ellipse. The rotation of the wave generator causes the meshing of flex spline with the circular spline to move around circumference. Since the flex spline has 2 teeth less than the circular spline, rotating the wave generator leads to a relative movement between the flex spline and the circular spline.
The backlash error can be eliminated because of the flex spline. The teeth is going to
harmonic drive gears and servo actuators are used wherever zero backlash.
You can able to get the application of whatever the drawbacks what we're going to be having, that can be limited in this one. Okay, so this is some of the sectional views of the KUKA robot, how this particular the DC motors is going to be incorporated for the in the 3 links. Suppose this is going to be a 3 link, 3 links are there. This is going to be one link 1, link 2, and link 3, and these are the 3 DC motors which are going to be used. Motor 1, motor 2, motor 3. These 3 motors are mainly used to move this particular links of this particular DC motor, and to transfer this particular torque to this particular links, we are going to be using this particular gears and the belt drives, which are going to be mainly used in this particular the KUKA robot what going to have. So in this particular video, you can able to see the exact the DC motors, how we can able to have. This is going to be the DC motors which are going to be used in this particular robot system. So here the belt drives and the gearing system can be used to different links of the robot portfolio. The transmission systems will able to transmit the torque from the DC motor to this particular links. So this is the 3 motors which are required for the 3 links movement. This motor is moving, then the link 1 is another motor will move. Okay, another link too is going to be moving depending upon this motor cases. That is how in the robot system the DC motors can be used. Okay. In a case,
This is axis 5.
so this is how the gears and the belt drives transmissions are mainly used in the Kuka robot what we're going to be using there. Okay, so these are all the some of the DC motors which are going to be used mainly used in the robot system, and the specifications also we have the torque specifications and the speed rating will be used at team. Okay, so next important thing is whatever the Kuka robot which we are going to be using that is the industrial robot and it is going to be having a maximum of 6 degrees of freedom. Okay, so now we are going to be having, and that is going to be a very heavy robot which is weighing about some 1000 kg weight will be there, and that will be mainly used in your industrial applications like assembly, painting applications what going to have. Okay, so now we are going to got some new robot which is going to be called as a DLR2 robot which is mainly very light robot which is good looks like this. This is going to be the light robot. It can able to weigh up to 50 kgs only, and it will able to contain the exploded view will be contained like this. So it will able to contain the joint, the fiber will be there. The outside is all fiber, whereas in the Kuka robot outside will be all it is going to be metal, iron metal will be used here. And we are having the exploited view will be looks like this. We are having the electric motors will be there, the harmonic drives will be there, and finally we are going to be having the position and the sensors are going to be using that one. Okay, so this is mainly used the robot for the human applications like that. This type of links which are going to be used, the humanoid robot manipulator can be used for this particular applications what going to have. Okay, so this small video can be able to show you how this DLL 6 robot can be used. Okay,
presents a humanoid two-arm system developed as a research platform for studying dexterous two-handed manipulation. The system is based on the modular DLR Lightweight Robot 3 and the DLR Hand 2. Hands and arms are combined with the 3 degrees of freedom movable torso and a visual system to form a complete humanoid upper body. The mechanics has been designed such
here
that
you can able to see here the weight of this particular robot is total 55 kg and the degrees of freedom is 43 and the total for the hands. So how can anyone type in the chat box for how many degrees of freedom our human hand will have starting from your fingers to your shoulder? How many degrees of freedom on your human hand will have? Can anyone type in the Google? Can anyone type? Can anyone know any idea? How many degrees of freedom? 180. No. So I am asking up to the fingers also. If you consider the fingers movement also, how many degrees of freedom we are going to be having? Yeah, good. Someone has told 27. That is clear. Good. So the 27 degrees of freedom is going to be there for single hand from our shoulder to the tip of the fingers. And this the 27 plus 27 we are going to be having how much? 54. So two hands of human can able to have 54 degrees of freedom, whereas this robot is having only 43 degrees of freedom. Still they are having 11 degrees of freedom less. Okay, but still it is going to be near to human.
and the system is able to reach objects on the floor as well as on a shelf of 2 meters height. It also has anthropomorphic kinematics to allow research on bimanual grasping. In the overall
applications what we're
system,
going to
the
be
robot hardware is connected to a
Okay.
hierarchy of
So
sophisticated
this
control
robot hand
algorithms running in the
is going to be
kilohertz
using
range.
presently
Moreover,
this
a tight coupling
DL
to higher level
the
modules for
robot arm
user
will be used in
interaction,
all the applications
perception,
also
and planning
for
is
dealing with
provided.
the
Our
that
agile
applications,
robot
you
development
can able to
software
buy this particular
concept
thing. It will be cost less only, so that you can able to do all the remaining applications what we do. Okay. So then another important thing which are going to be required is the accuracy, repeatability and stability is going to be another important thing which are going to be required for the robot selection. That can be done by using this particular small trial and error method, which can be done. Okay. So next, now we are going to be coming. These are some of the different actuators and the transmission elements which are going to be required in the robotic links what we're going to be having. So now we will able to discuss about what are the different sensors which are going to be needed for your robots. Also, we can able to discuss in this particular class what we're going to have. So as I already explained you, we are having two different types of categories of sensors which are going to be there in the system. We are going to be having internal sensors and outer sensors what going to have. So first we will be able to discuss what are the different internal sensors which are going to be required for this particular case. Okay, so these particular internal sensors, so we are going to be having the potentiometers, variable inductance transducers, eddy current transducers, and variable capacitor transducers are these are going to be mainly used. First, we will able to see the potentiometer sensors, which will able to mainly contain. It can be mainly used for the linear or rectilinear motion, or the rotary motion also can be used. It can able to contain a carbon or platinum, or now we are going to be having some conductive plastic is also will be used as a potentiometer material, and this particular will have the movement of this particular slider. Depending upon the movement, the resistance will be changing and can able to read the particular change of resistance will be corresponding to the voltage. That correspond voltage will be indicates the what is the displacement of the particular case what we have. Similarly, for the rotation of the theta also, the depending upon the slider rotation, we are going to be getting the output voltage, and that will be correlated to the angle what we're going to be having. Okay, so the main disadvantage of this particular potentiometer is since the slider is moving there, we are going to be having some mechanical load is going to be occurring. Because of that, we are going to be getting some some disturbance in the measured signal will be coming. So since the mechanical vibration is going to the slider is continuously moving on that one, we are getting some error signals also will be coming. Okay, so the main advantage is it is going to be a robust, simple, and inexpensive. It is very less cost. We can able to get it in 100 to 200 rupees. Also, we can able to get the potentiometer what we're going to have. Okay, so to overcome that particular thing, now the people have developed one optical potentiometer. Okay, so this will also comes under the optical potentiometer, where the light instead of the slider, the light is going to be moved on this one. We are having a photoresistor layer will be there, and the resistive layer will be there. When the particular light is going to be moving on that one, the photoresistance resistance because of the particular light. The resistance of this photoresistance layer will be changing. So because of the change in the photoresistance layer, you can able to calibrate the displacement what we're going to be having. Okay, so next we are going to be having the variable inductance transducers are going to be another thing where we are having three different types of the transducers what we're going to have: mutual inductance, self inductance, and permanent magnet inductance are the three important categories what we're going to have. Okay, so now we will able to see one by one this particular case. The mutual inductance transducer also will be called as the differential transducers also will be there. Okay, so it will able to contain two coils will be there, one primary coil and the secondary coil, and we are having one moving the ferromagnetic element will be there, that is going to be called as the core. Okay, so if the by movement of this particular the ferromagnetic element in a flexed path, the change we can able to measure the displacement called as a LVDT or RDT will be application is going to be mainly used. Okay, if you are going to be using the moving the coil is moving itself, so the core will be constant and the primary is constant and secondary coil is moving. That is mainly used for the resolver. So this is resolver is mainly used for the adjustment of the rotary displacement in any particular robotics. We can able to use the resolvers are mainly used there. Okay, so now this is going to be the main principle. application, what we are having the secondary coils by movement of this particular thing, this animation you can able to see. So this animation you can able to understand. This animation is not coming. Yeah. So here you can able to see by movement of this particular core, the voltage generated in this particular section 1 and section 2 is going to be changing, and the difference of this particular thing is going to be changing, will be considered. So this is the difference will be, this is the curve. Okay, so it will able to become, when this is going to be exactly equal in length, we are going to be getting a zero deflection. It is by moving the deflection is going to be changing what going to happen. From that you can able to measure the both direction, negative and positive directions also can be measured by in this particular case. Okay, so we need some similarly we can able to have the rotary inverter case, where in place of that particular the ferro element core will be in the form of this particular rotational form. So by movement of this particular thing, we can able to measure the rotation also, we can able to do that. Okay, so next important thing is the inductive proximity sensors. We are going to be having the inductive proximity sensors are mainly used by using the same the inductive principle. Whenever an electromagnetic coil detects the metallic objects only. So this whenever it is going to be metallic object is going to be coming nearer to this particular thing, we are going to be getting a signal is going to be there. So the main drawback of this particular inductive proximity sensor is it can able to work only for the metals. If you place any particular plastic material, you cannot able to get the signal. Okay, it should be compulsory a metallic object what going to have. Okay, and the distance can be, it will be a 5 to 15 mm distance. It can able to use that one. Okay, so this is the working principle. We are going to be having the one or two reference coils will be there. One sensing coil will be there, and one reference coil will be there. And whenever any particular metal object is coming nearer to this one, the sensing coil, the induction, both will have the reference coil and the sensing coil will have the same induction will be there. Whenever any metal coming near to this one, the sensing coil induction and the difference between these two will be changing. That will be indicated as the change in the particular case. In the market, this is going to be the type of the proximity inductive sensors will be looks like that. Okay, so next this is mainly used for measurement of the transverse displacement or small displacement or non-linear displacement. At the same time, it can able to use as the absence or the limit switch also. So if you are going to see here the object is present or not, we can able to identify by using the limit switch principle. At the same time, you can able to measure the gear tooth profile also. You can able to measure that is the non-linear displacement also you can able to measure by using this particular the inductive sensors what going to have. Okay, so next is the capacitive proximity sensors. These can able to do detect both metal and non-metal objects also can be sensed by using this particular thing. Okay, and the sensitive distance is a few hundred centimeters also we can able to measure. Okay, so here in this case what we're going to having is we are going to be having one oscillometer will be there and one dielectric plate will be there. And this oscillometer will able to generate the vibrations and depending upon the target present near, we are going to be getting the target near presence, then we are going to be getting the higher signal echo is going to be coming. When the target is absent, we are not able to getting any excitation will not be there. That is how the capacitive difference will be there. So this the capacitive proximity sensors, depending upon the dielectric constant various metals, we will able to have the variation will be there. So if the dielectric constant of the substance, the larger the dielectric constant of the material, it is easily detected. Okay, so if you see here, alcohol is going to be having higher, glass is going to be having 5. Okay, and water is going to be having some 80. So water is going to be having some 80 dielectric material like that. So for this is going to be one example how we can able to see if that particular milk or water is going to be filled in a particular plastic bottle, what we're going to have. So that is how, because since the water dielectric constant is higher than the plastic material, we can the proximity sensor can able to detect exactly how much liquid level has been incorporated in this particular the milk bottles, which can able to detect easily what going to happen. Okay, so the size of this particular thing. So suppose you are going to see the size of this particular, it is going to be having lesser, and this is going to be diameter is going to be bigger, and this is going to be there. Okay, so the larger diameter of sensor will indicate the larger span. Okay, the span means what is the minimum you can able to the difference between the maximum measurement to the minimum measurement, that is going to be called as the span. Okay, if you are having a want to have the larger span, you have to go for the higher diameter sensors what we have. Okay, so next important thing is the ultrasonic proximity sensor. So it will works on the principle of the reflection of the ultrasound case what we're going to be having. So we can able to use it can able to generate one reflection, one receiver, and one generator will be there. It will able to generate ultrasound when the object is going to be hit. The receiver will be able to get the echo signal, and from that it can able to measure the distance also can be measured by using this particular ultrasonic proximity sensor. So this type of ultrasonic proximity sensors are mainly used in your robotics applications to identify the obstacle evidence can be identified by using this particular ultrasonic proximity sensors can be mainly used for the case. So the main drawback of this particular ultrasonic proximity sensors is the operation. It will able to have the different dead zones will be there. We are going to be having some different dead zones will be there, and we in this particular dead zones cannot able to operate. So if any particular object is going to present 60 to 80 centimeters, cannot able to detect that. Okay. At the same time, if the object is not inclined position like that, then the reflected wave will not be received. So it should be in a correct position, exact 90-degree position only it can able to. That is the two drawbacks with this particular ultrasonic proximity sensor what we have. So we are having similarly microwave sensor and optic sensor, and these are all the different proximity sensors which are going to be used in different applications in the automation industry. We can able to use in the conveyor belt, food manufacturing plant. Okay, and these cases which can able to use that one. Okay, so these are all the inductance sensors. That is, we can able to have by changing of the inductance or the capacitance, we can able to have the proximity sensors are mainly used that one. Okay, similarly. Permanent magnet transducers or the DC tachometers are mainly used for the measurement of the rotation measurement. Okay, so here the induced voltage what we're going to be having that is directly proportional to the speed of the conducting crossing magnetic field. That will be depends upon the rectilinear speed or the angular speed can be measured by using this particular the DC tachometers what we have. Okay, so now similarly by changing the capacitance also we can able to measure the different applications. As we know that the capacitance is C is equal to Ka into X. Okay, so where X indicates the gap width, A indicates the overlap area, and K indicates the dielectric constant. So by changing any of this particular thing, we're going to be able to have. By changing a charge, you're going to be having a charge amplifier, which is mainly used in the cutting force measurements of the machine tools. We are going to be having the dynamometer will be used there. The piezoelectric dynamometer, which will able to contain the charge amplifier, is mainly used there. So that is mainly used by changing the charge. Okay. Similarly, by changing the voltage, we are having a high impedance device in parallel, and by changing the current, low impedance device in series will be connected, and we are going to use the different applications by using this one. Okay. Similarly, so the capacitance piezoelectric transducers also we are going to be having piezoelectric sensors. We are having, as you know, that the piezoelectric materials such as beryllium, titanium, the quartz, and zirconate titanium generate the electric charge when you apply a force. So we take this particular thing. If you apply a force on that one in the upward direction, you can able to generate a voltage is going to be generated. That is going to be mainly used by the piezoelectric applications what we have. Okay, so these piezoelectric mainly used in the piezoelectric accelerometers are mainly used. At the same time, the force sensors, as I already explained, piezoelectric the dynamometers for the measurement of the cutting forces. We are going to be having the touch screens, whatever your mobile phones, what we're going to be having the touch screens, how it is going to be working. That is mainly contain the piezoelectric sensors are going to be there in your mobile touch screens. Okay, and this is mainly used for the piezoelectric sensors. What we're going to be having. Just I will. These are all the different materials and the things. Okay, so next is the effort sensors, which are used in the robotic applications. We are going to be using the effort sensors. Okay, so how much effort is going to be inputted? That is, effort will be in the form of a force or a torque. Okay, so if you want to measure the force or the torque generated in this particular robot, then we need the different types of effort sensors are going to be mainly used. Okay, so these effort sensors or the torque sensors are mainly works on the principle called the strain gauges are mainly used for measurement of this particular torque and force measurement. What going to go? Okay, so here a metallic foil of copper nickel alloy constant will be wrapped between this particular thing, and they are going to be placed on a particular cantilever beam, and if you apply any particular force on that one, this strain gauge also will undergo some strain or the change in length and diameter of this particular strain gauge, and correspondingly change in this particular thing, we can able to measure the forces what we're going to have. That is how these particular the strain gauges are going to be working principle what we are going to be having. So just by using this particular Wheatstone's bridge technique, you can able to measure the change in resistance in this particular the strain gauge, and corresponding the voltage change, you can able to calculate what is the force acting on this particular applications what going to have. Okay, so so these are all some of the important the strain gauge materials, and we are going to be having some this gauge factor or the sensitivity is going to be one of the important thing which is going to be required for the calibration purpose. So depending upon your application, you have to select which type of strain gauge is going to be required for that one. You can able to see that one. Okay, so similarly for the torque measurement also, the same strain gauges are going to be kept on the shaft whose torque has to be measured. That will be used. So like this, you can able to arrange the strain gauge on the particular shaft, and whenever the torque is going to be applied on that one, the shear load is going to be occurring on this particular strain gauges, and correspondingly the resistance is going to be changed, and that resistance will be measured by in this particular Wheatstone's bridge, and you can able to measure this particular torque measurement. Also, you can able to do that one. Okay, so in your robotic arms, this type of strain gauges are mainly used. At the same time, at this particular end effector, we are going to be having the strain gauge force sensors also will be there. Okay, so depending upon these particular force sensors only, you can able to have the tool operation is going to be mainly done with one. Okay, so just I will show you on this particular video where this particular strain gauges, how it will able to looks in any particular robot arm what we're going to be having.
We're
So
scientists,
this is
right?
going to
That's our
be
job.
at
And so
the
data is
end of the end
everything,
effector,
and
we are going
reliable
to
data,
have
repeatable
strain gauge,
data,
which is going to be
or
used there.
simultaneously
This is
in
the
all
strain
6
gauge
axes,
we are going to be
force,
having.
XYZ,
So this the inner components also
spokes
you
or
can able
beams
to see.
connecting them.
It will able to
Each beam
contain
has
the
4
bridge
silicon
circuit.
strain gauges that function in pairs to form half bridges, force XYZ and torque XYZ.
So
When you look
these
inside
will be
the
the internal
ATI force torque
components.
sensor, you can imagine it resembles a wheel with an outer wall, with an inner hub, with spokes or beams connecting them. Each beam has 4 silicon strain gauges
So
that
four
function in
silicon
pairs
strain
to
gauges
form
this
half
will
bridges.
able to contain,
The
and
output of
that
the
will
transducer is 6
depending upon the
channels of strain
deflection,
gauge
you can able to
voltages.
measure
The output is
the force is going to
digitized
be
and
measured
then
by this
converted to
particular
force and torques.
the strain gauge can be used that one. Okay, so here the same we can able to have, as I explained you, they are having these are the different strain gauges are going to be kept on this one. They can able to get the 4 deflection elements will be there, and from that we're going to be getting the the strain, the force torque matrix are going to be coming like this, or the force and bending matrix are going to be coming, and this is going to be called as a correlation matrix. By multiplication of this, we can able to get what are the forces we can able to apply on this particular, and the deflection multiply by this, you can able to get the force and the moment you can able to calculate for this one. Okay, so this is how the strain gauges are mainly worked. So why we want this particular force strain gauges are there in the robotic applications. If you want to make a assembly operation, suppose I want to fit this particular object or nut. I want to fit a nut is going to be we are going to be having a particular portion. I want to fit a nut here. So then I have to apply approximate force is going to be applied. So how much force has to apply, that also we can able to determine by using this particular force sensor. Okay. Similarly, this is going to be one polishing operation is there. I want to make this particular, this is going to be some crankshaft is there. I want to give some polishing to that one. Okay. So polishing, how you can able to do this is the one grinding wheel is going to be rotating on this particular grinding wheel. If you keep this particular crankshaft and apply force on that particular crankshaft, then we can able to get the grinding is going to be occurring on that one. So that is to measure that particular thing. You have to need this one. This force sensor and torque sensor is going to be required. So here is going to be application where this is the pressure, the force sensor which is going to be applied, and this is going to be the grinding belt, and how much force is going to be required to get this particular polishing. You can able to calculate by using this particular force sensors what we're going to have. Okay, so these are all some of the important the torque sensors which is going to be mainly used. So next is the tactile sensors. The tactile sensors are which are mainly used in the robotic application for the safety precautions applications we are going to be using. Okay, so how these tactile sensors are working is that we are going to having a two deflection surface will be there. This is the surface 1 and this is going to be surface 2. Okay, so the surface 2 is going to be a standard one, or the reference surface, it will not move. Whenever you are going to be applying any particular force is going to be applied on that one, this surface, this portion is going to be get deflected. Okay, and we are going to be having one light laser will be there, which can able to measure what is the deflection you are going to be getting. Okay, from that you can able to indicate that the tactile sensor some applied forces is going to be applied that one. That is how you can able to measure that one. Okay, so we are going to be having optical tactile sensors also will be there. We are going to be having the optical tactile sensors will be there like this. This is going to be the working principle. The receiver fiber optics case which are going to be there, and they reflected. So this is the same thing which the Palney has explained. That is optomechatronics. Okay, this is the same application. This optomechatronics will be able to contain these tactile sensors will be able to contain one of the best example for this particular optomechatronics what we're going to be having. So similarly, we can able to use the laser interferometer interface also we can able to use. Okay, so what we will do is the deflection object is going to be there. We will able to have the split beamer will be there. The laser will be splitted into here. Okay, some portion of the laser will able to go inside and some portion of the laser will go back. Okay, so it will able to come to this particular portion and go back, whereas another laser will able to go and come back. The distance is going to be 2. Okay, the difference between the phase angle difference between the deflected laser and the original laser coming out from this particular laser, that is going to be calculated, and that gives the phase shift formula. And from this particular phase shift formula, we can able to measure how much distance this particular object is going to be there. That can be identified by using this particular the laser interferometer technique what we're going to have. Okay, so similarly, we are going to be using the laser Doppler interferometer also. This is the same technique where we are going to be having the reflected beam will be received. So in that case, we are going to be using the beam splitter will be in a vertical position. The laser will come and here hitted, and one portion of the beam will be goes back, and another portion will able to go inside and hit this particular object and go back this one. Okay, from that also you can able to measure how much speed this particular object is moving. Also you can able to identify by using this particular laser parameter what we have. So these type of sensors are mainly used for robot safety applications. Suppose if you see here, the
Unpredicted
safety
movements,
applications, whenever
component
any particular
malfunctions,
person
or
is
unpredicted program
human being
changes
is coming
related to the
suddenly,
robot's arm or
because the robot
peripheral
cannot able to
equipment
identify the
can
human
result
being,
in contact accidents.
it can able to harm
This
the particular
involves
human being.
incidents
What
such as being struck by
okay.
a moving
So
part of the
in
robot.
that case, we are going to be having different types of environmental proximity control types will be there. One is the fence type, that
The
is old
advantage
type.
of a
We are
fence
going to
type
be having
barrier is that it is capable of
I think
stopping a
in your
workpiece which might be ejected by the robot's gripper
if
while
you're
in
having
motion.
a fencing,
The barrier should be high enough to prevent a worker climbing over it.
So next important thing is the interlocking gate barriers will be there.
This
We are
animation
having
shows the layout
this
of the
gate is
physical
going to have the
barrier
proximity
enclosing the
sensor where any
perimeter of
particular
robot
person
work
is going
area.
to be entering into this
The barrier should
particular
be with its tooling.
case.
By using
The
an
proximity
interlock
sensor
gate,
will able
if the
to alert
gate
this
is
particular
open, the
robot, and
robot
the
within the work
robot will
envelope
stop
immediately
working.
stops working.
Stop working. Here we are going to have the light curtains comes under this tactile sensors. What going to have. So here we
The
are
robotic
having the light
welding work
curtains
cell
and
shown
it
here
will
is
be
guarded on all
there
four sides.
when
The back of the work cell
person is
uses
going to
a
be
control
entering this
panel and
particular
hard
case.
guards to prevent entry
The
to the
light
safeguarded
curtain,
space.
the light
The
will
wall
be
must be high enough to ensure that no one can reach over it into
thing,
the
and
protected area.
automatically the signal will be given to the particular robot to go for that one. Okay. Similarly, the horizontal light curtain barriers also will be used
This
in
animation
the
shows
robot
an example of a
applications
perimeter
where
guard safety light curtain
the
with
light
horizontal
horizontal
beam
light beams are
detection.
going to be
As
applied
a
when any
perimeter
person
guard,
is
the safety
enter
light
into the
curtain detects
particular
anyone
one
or
space of the
anything
particular
entering the
robot.
robot's work envelope
Automatically, it
and
will able
stops
to
the
give
robot
the alert
immediately.
signal for the
The
particular robot.
robotic
It
work
will
cell
able to
can't be
stop that particular
reactivated until it has been cleared
thing,
for
so that it cannot
operation by
able to harm the
personnel at
particular
an
robot.
outside station.
Okay, so these are all some of the important sensors which are going to be mainly used. And the temperature sensors are the thermocouples, which are one of the important the temperature sensors which are going to be used, which will works on the Seebeck effect. As you know that this is going to be one broad classification of the different types of sensors which are going to be used, and what are the different ranges which we can able to have. So this is the potentiometer, LVDT, resolver, tachometer, eddy current proximity sensor. Okay, so load cell, this is the laser. These are all some of the important sensors which are mainly used in the robotic applications what we're going to be having. Okay, so next important thing is the digital transducers. This is comes under the encoders. Okay, the shaft encoders will able to come as the digital transducers what going to have. So this is shaft encoders. We are going to be having two different types of encoders will be there. One is incremental encoder and absolute encoder. The absolute encoder will able to give the exact value of the particular the display, the rotor displacement, or the rotor will be there, whereas the incremental encoder will able to give the relative position of this particular the relative position will be given by this particular the incremental encoders will be able to give. Okay, so the shaft encoders, the techniques which are going to be used is the optical method, the sliding contact, the magnetic saturation method, or proximity sensor method are going to be mainly used at that time. Okay, whenever you are going to be having the sliding contact, this optical encoders will be able to have a light passage will be there, a small portion will be cut, and this is going to be rotating on that one. Because of this particular sliding contact, we can able to get the case, but this is not that much use. The magnetic, this is the proximity sensor type will be there, where we can able to use the proximity sensor, and the light source is going to be kept here. Whenever this disc is rotating, the light will able to get fall on this one, and it can able to detect that particular the pulses can be detected by this one. Okay, so the important thing is this absolute optical encoders are the coding is going to be one of the different things. So we are going to have two different types of coding will be there. One is the binary coding and the gray coding. This gray coding will be considered as the ASCII code, and the binary coding is going to be the exact coding. And this coding is going to be to make this particular coding. This is going to be extremely costly. Okay, if you want to make this costly, depending upon the accuracy and resolution, the disk cost is going to be increasing what going to have. Okay, so that is how the coding depending upon this particular coding. If you see here, we can able to consider as a 2 to the power of 0, 2 to the power of 1, 2 to 2 square, 2, 3 like that. We can able to give the codes. Okay. So and each case we can able to get the binary code value 0 or 1 or 2 like that. You can able to get the and how many revolutions this particular has made. You can able to identify that one. Okay. So the absolute encoders. The main advantage is the homing is not required. Okay, the homing means the start point. Okay, suppose you are going to rotating this one, this is going to be the start point and this is going to be the end point like that. You can able to have this. Homing is not required. You can able to start any one and you can able to measure that one. Okay, so the absolute encoders are very costly. So to overcome that one, we are going to be having the incremental encoders which will able to contain 3 disks will be there. Okay, one will be the center disk will be needed for the homing representation. That is going to be considered as the reference disk. Okay, and another 2 disks which are going to be used for the application. So here by using this particular, you can also identify the direction of the rotation. Also, you can able to do. So suppose here 0, 1 is there. The code, if it is rotating in this case, the 1, 0, 1 is coming. 1, 0 is coming. So depending upon that case, you can able to detect that it is going to be rotating in clockwise direction or anti-clockwise direction. Also, you can able to measure that. That also you can able to do that. Okay. So now this is all the incremental encoders are very cheaper in rate. So that's why we can able to use. But if you want to have a more accurate measurement, so suppose if you want to use in the Land Rovers like that, in the space applications, then you have to go for the absolute encoders will be used for the measurement of this one. Okay, so these are all some of the important encoders which are going to be there. So now coming to this particular MEMS sensors, we are going to be having the MEMS sensors. Just I will give you a brief idea of this particular thing as we are going to be having one complete session on this MEMS sensor on 8th. We are having a main these accelerometers are mainly used in the automobile applications. So we are having the flow sensors, gyroscopes. These are also will be used in automobiles. Humidity sensors, light sensors, magnetometers. So these magnetometers, gyrometers, and accelerometers. These 3 are mainly used in your automobiles. So for your stability analysis or ABS analysis, for your track analysis of all your automobile will be done by using this particular 3 sensors what we're going to be having. Okay, so the main applications, the main principles on which this is going to be working is the piezoelectric, electrostatic, or electromagnetic. So these are the main important things. So as in the previous case, we have seen inductive, resistive, and capacitive. That are the 3 principles on which this particular sensors are going to be working. The major bigger sensors what. So whenever you are going to be coming to this particular MEMS sensors, these are the 3 important laws on which this particular MEMS sensors are going to be working. That is a piezoelectric or electrostatic or electromagnetic are the 3 important sensors for 24. Okay. So now I will able to explain you what are the different MEMS sensors which are going to be used in an automobile point of view. Okay. So remain sensors in the automobile point of view. I will able to give you. We are going to be having 2 different types of so 2 different types of safety will be there. So we are going to be having 2 different types of safeties will be there. Okay, so one is the passive safety and the active safety are the 2 important the safeties will be there. So the passive safeties means this is going to be your seat belts, your airbags opening, or multiple airbags opening. This all will comes under the passive safety in the automobile. Okay, and in the active safety means your ABS system all will comes under that is going to be comes under comes under your active safety elements what we have. So here this is going to be the active safety and passive safety what we have. So in the active safety we are going to be having the hydraulic braking system. Okay, So electric braking system, the stability management system, and accident prevention system. This all will come under the active. Okay. So when this active safety will be able to mainly used when the vehicle is running, how to prevent the accident. Okay. So if the accident is cannot be prevented, then also we have to have the safety should be there. Then we can able to consider this is the passive safety will able to comes. So the main things we are going to be coming is the airbags is going to be mainly used there. The airbags are only mainly working principle is going to depends upon the MEMS accelerometer what we're going to be having. Okay. So in this particular MEMS accelerometer, how this working principle is there, this is going to be how the airbag opening will be there. So this animation you can able to see it will able to have then one comb like structure will be there. So when the comb like structure will be there, so here in this particular case this comb like structure will able to generate the change in capacitance of the plates. Okay. So whenever it is the car is hitting here, we are going to be getting the comb structure is going to be moving here. Okay. So the comb structure is going to be moving here. Okay. So here I will able to explain here in this case you can able to understand in a more clear manner. So here this is going to be considered as the inertia mass, and we are going to have this is going to be the capacitor plates, two plates of the capacitor. Okay. So when and this inertia mass is going to be loaded in this particular spring loads. This is going to be the spring loads, that is the flexible beams. Okay. So whenever any particular jerk is going to be occurring, this inertia mass will able to move between these two plates. Okay, between these two plates, this inertia mass will able to move. Okay. So because of this particular change in distance between these particular capacitance plates, some voltage the capacitance change is going to be occurring. Correspondingly, some change is going to be occurring. So that will be detected as the by this particular accelerometer, and that will able to activate your airbag openings will be done that one. Okay. So but if you see this particular accelerometer, it will looks like this. It is going to be very, very small. Okay, it will be the size will be in less than 1 centimeter. The size will be the length and breadth of this particular will be less than 1 centimeter, and it is going to be the accelerometer how it is going to be looking. Okay, so so that that is how this is one example I have shown you. So the remaining examples are these accelerometers are mainly used for identification.
Cause change in capacitance
So here
with the straight flow. And first, let's register. In the loop sectors of the X, and when an external will correspond to it, use the whole effect, use the Mach 100 the angle value.
So this is how
that with the same metric that location is explain how each of also with the accelerometer it measures acceleration by measuring change in capacitance. Its microstructure looks something like this. It has a mass attached to a spring which is confined to move along one direction and fix outer plates. So when an acceleration in the particular direction will be applied, the mass will move and the capacitance between the plates and the mass will change. This change in capacitance will be measured, processed, and it will correspond to a
that is how the working principle of this particular the accelerometer is going to be occurring. Okay. So other types of sensors we are going to be having the thermal accelerometer. This the SAR will able to explain. This just I will able to skip this one. So another important area what we are going to be the people are mainly working is the energy harvesting. Okay. So why this particular energy harvesting is going to be coming is now people are going to be using a lot of sensors are going to be using in any particular company. So if suppose you are going to take any particular manufacturing company, we are going to be you are going to be using some 2 lakh different sensors are going to be used there. Okay. So for that one, so to supply the power to this particular 2 lakh sensors, it will be if you are supplying only less ampere times also, but if you are going to be supplying for a 2 lakh like that, and if you are going to be considering the number of sensors is going to be increasing in such a manner that the power consumption is also will be increasing. Okay. So to overcome this particular thing, the people are going to be using some energy harvesting devices which are going to be used. Okay, so these energy harvesting devices, they will generate their own power and they can able to supply their own power to themselves. Okay, similarly, if you see here this particular aircraft system, we are going to be using one different piezoelectric energy harvesting sensors are mainly used, which can able to generate their own power and they can able to give the signal what going to have, so that you can able to save the power what going to have. Okay, so we are having the potential energy harvesting. We are going to have different techniques are there. We are having AC rotor generators are there, AC rotor linear generators are there, piezoelectric elements are there, electrostatic generators are there. Okay, electromagnetic generators are there, inductive coil generators are there. Okay, photovoltaic cells. This is by using the solar energy, and by using the photoelectric generators are there. They will able to take the thermal energy and able to generate the thing. Okay, similarly the electrochemical reaction, they will able to take the biological and chemical energy and they can able to generate. So like that, depending upon the different types of things, we are going to have different energy harvesting sensors also coming into picture. This is going to be a big area where people are going to be working case. Now, because of this particular industry 4.0, we are going to be getting a large number of sensors are going to be incorporated in your applications for that case. Okay, so just I will skip this one. So this is going to be the different fabrication techniques, everything they will explain. So now we will be able to see one small glance I will able to give you how you can able to have the evolution of the different sensors which we can able to okay, so which we can able to have use in the automobile industry. So the evolution of car is going to be occurring like this. We in 1977 now we are going to be having the different the cars what we're going to be using different types of sensors are going to be incorporated. These sensors you can able to have this is going to be one example where you can able to see the evolution of cars starting from now we are going to be using the electrical cars. So just an electrical car means we are going to be having a battery only electrical car where the battery power is going to be used. So this is going to be this type of electrical car. We are having the plug-in hybrid electrical cars will be there, and extendable electrical cars will be there where this battery is get heated. Okay, so here we are going to be having the combustion engine will able to work first, and correspondingly the battery is going to be get charged. Okay, once the battery is going to be charged here, automatically this battery will able to supply this particular current. This is going to be called as the plug-in electric vehicle what going to have. So the extendable plug-in electrical vehicle means they are going to be replacing a very big battery is going to be replacing and they will able to charge this particular battery to a particular extent, and first the battery will able to work. After that, once the battery charge is going to be totally over, then the internal combustion is going to be working. That is going to be called as the extendable electrical vehicles what going to have. These are all some of the evolutions what are going to be happening in the automobile industry. Now we are going to be coming to this connecting cars and autonomous cars also coming into picture. Okay, so just this particular video will able to show you what are the different just I will show we are having 4 different types of revolutions are going to be occurring here, starting from industry 1 revolution where the steam based machines are going to be mainly used. Okay, the steam based machines are mainly used for the power generation. So next we are going to be having a second revolution where the electrical energy is going to be mainly used. Okay, in the third evolution we are going to be having the computers are going to be playing and they are going to be mainly used for your applications what going to have. Okay, so next we are going to be having the industry 4th revolution where we are going to be using both the integration of artificial intelligence and information technology is going to be mainly used in this particular revolution. Okay, so in this particular Industry 4 revolution, we are mainly concentrating on the cyber physical systems what we want to be on. So that is the cyber physical systems. Okay, the cyber physical systems. Okay, that is the mainly used in this particular case. The cyber physical systems means these systems can able to communicate with each other by using the Internet of Things sensors. So we are going to be having the Internet of Things sensors are going to be there by incorporating this particular Internet of Things sensors. These machines will able to communicate with each other in a wireless manner, and they can able to take their own decisions depending upon the artificial intelligence what we have. That is going to be called as the Industry 4 revolution what we have. Okay, so now in the evolution of the cars also, we are going to be getting a different evolutions are coming. First, they will start with the R&D, where in the first R&D they will able to in 60s to 85s the mainly concentrated on how you can able to increase the efficiency of the car. Okay, after that we are going to be giving the embedded era, where some electronics are going to be coming into play. So that is electronics coming into play, like we are going to be having the automatic the opening of windows. Okay, so electric steerings, that all will be able to come in. So after that we are going to be having the informatic era. So in this particular informatic era, your dashboard is coming. So we are going to be having your cars, we are having one dashboard will be there, which will able to contain the different information like your how much fuel is going to be consumption, how much speed the car is moving, how much mileage it is going to be giving. That information at the same time we can able to have some entertainment like the FM phones, everything will able to come to era. Okay, so now present we are going to be coming into this particular era called the vehicle to vehicle era. So V2X era. So in this particular V2X era, we are mainly using the IoT sensor based communication will going to be mainly used, where the mobiles can the cars will able to communicate with the V2X means vehicle to vehicle. So the vehicle to vehicle will communication will be there, V2V, and we can able to have vehicle to the structure. That is surface structure means we are going to have the road is there. So this is going to be the road and the vehicle is moving like this. Okay, and is that particular turning is going to be occurring, or in the another 10 minutes the bridge is going to be coming, that will be communication. That is the vehicle to the structure communication also will be there. Okay, so vehicle to vehicle communication, vehicle to structure communication, and vehicle to infrastructure communication also will be there. Okay, so these are all three different types of communications which are going to be dying in this particular year, and this is going to be considered as the Industry 4.0 era what we have. And finally, the people are going to try for the autonomous vehicles, where the autonomous vehicles are going to be considered as the cars which we can able to have the autonomous vehicles. They can able to the self-driving cars what we're going to be having. Okay, so these are all some of the important building blocks of Industry 4.0. So these 9 pillar technologies are mainly used in this particular case. So we can able to use Internet of Things, cyber security, cloud computing, additive manufacturing, the supply chain management, big data analytics, autonomous robots, and the simulation and augmented reality. These are all some of the important the building blocks what we're going to be using in the case of this case. Okay, so now by using these particular things, they can able to have the IoT based tracking car system, as in your Uber and Ola. You can able to track your car, where the car is going to be coming, which place, where it is going to be coming. Everything you can able to track the car. That will be done by this particular thing. Okay, so the different IoT platform devices what we're going to be having is we are presently we are going to be having the different hardware boards are available, like Arduino board, Raspberry board, okay, Bitlin board, Intel and Intel Galeno what we're going to have. So among all these things, this Arduino and this Raspberry Pi is going to be one of the important boards. These are all these are the two popular boards what we're going to have. Okay. Hello. Hello, sir. Hello. Halogen phone in classroom. Okay, so these are all the important in the afternoon. We will able to write some of the programs on this particular Arduino board. How we can able to make the control programming by using this particular Arduino board. How you can able to do that. Okay, so this is how these Arduino boards are like a built-in boards which will able to contain everything. Okay, so your microcontroller and your signal processing, everything will be built in one small chip, and that will be used for your applications what you have. So for your IoT applications, this type of small boards are available where you can able to plug and play this type of boards, and you can able to connect different sensors, and automatically you can able to go further. Okay, similarly this Raspberry Pi, the main difference between this particular Arduino and this Raspberry Pi is going to be considered as the single board computer itself. So in the Arduino, we cannot able to have the operating system will not be there, whereas this Raspberry Pi will able to contain some the operating system will be there, the Linux operating system you can able to load, and it is going to be considered as the single board computer like that. So it is going to be acting like a single board computer, and you can able to make the at the same time it also will be containing some the wireless communication protocols also, and Bluetooth communication protocols also will be incorporated in that one. So you can able to connect the sensors, and the sensor data can be wirelessly communicated to your the central processing computer, and from that the data can be analyzed what we have. That is going to be one advantage. These are all built-in boards are available because of this particular built-in boards. Now the mechanical people also can able to play with this particular IoT devices what we have. So previously when if you when this particular Arduino and this Raspberry Pi is not there, you have to make your own printed circuit boards. So we have to make your own the IC board, the printed circuits has to be designed by yourself, and that circuit board has to be printed, and then this circuit board is going to be done, and automatically then only you have to make the programming called as machine learning programming, or the old programming which are going to be used for the microcontroller. The high level programs are going to be used, okay, by the EC people. Now automatically, because of this particular built-in boards are available in the market, and by using this particular Python programming, you can able to write the program code in a very easy manner by using this particular things. Okay, so this is going to be the architecture for the Internet of Things architecture. It will able to contain the hardware level. We are having the different sensors will be there, and the communication level, we are going to be having different communication level, and the software level and the application level. This application level will be considered as the cloud-based level, where the different cloud applications will be connected at one. Okay, so this is how the OT and IT layers of any particular manufacturing is going to be connected. So just I will the smart manufacturing concept. Just I will skip it. The vehicle to vehicle communication is mainly done. So this is mainly used for this particular applications. So this is how the main era of Industry 4.0, which will able to lead for the IoT based systems. Then for this case, now we are going to be getting this wireless sensor network is going to be playing another important role. Okay, so this wireless sensor network, what we're going to be having is we are having different sensors will be there. Suppose if for your applications, we need one humidity sensor, one accelerometer sensor, one gyroscope sensor is going to be required for your application. All sensors will be incorporated in single board, and the signal conditioning and microcontroller will be built in same board. Okay, so this is going to be called as the wireless sensor modes are available in the market. What we have, this is going to be another evolution which is going to be called as the modes. Okay, we are going to be considered. We are having different modes will be there. Okay, and automatically by using this particular modes, you can able to make the different modes will be arranged in different applications of this particular aircraft, and we can able to make the dynamic monitoring of the aircraft can be done. Okay, so at the same time you can able to make the health structure of the bridge also you can able to make. Similarly, you can able to make the telemedicine and the telehealth medicine also you can able to make by using this particular thing. Okay, so same thing. We are now the smart cities also. They are going to be using this particular the wireless modes what we're going to be having. Okay, these are a lot of applications which are going to be mainly used this one. Okay, so in the sea, in the water, underwater wireless sensor network also we can able to have this type of modes will be incorporated there, and you can able to explore the waves and everything. You can able to do that. Okay, so the standard the wireless networks are we are going to be having Wi-Fi, Bluetooth, Zigbee, and Sigma LoRa and wireless Halet. So for these are all some of the important protocols, the wireless protocols which are going to be used. Okay, so these wireless protocols for your present understanding, I will tell you. So depending upon the distance of communication. So suppose if you are having a lesser communication is there. Suppose from your sensor data, if I want your central computer will be in a less is distance is going to be less than 10 centimeters, then you have to go for the Bluetooth or Zigbee. Okay, so if you want to have a higher area communication, then you have to go for the Wi-Fi. Okay, so within the city, if you want to have within the city, then you have to go for the 6-LoWPAN communication is going to be mainly used. Okay, this is the and if you are, these are the two important things which are going to be mainly used within the city, and we are going to be having the LoRa is another important which is mainly used for the communication. These are all some of the important communications. It will take for me another one semester course to explain these things. Just for your understanding, these are some of the important communications which we can able to use in a wireless sensors network standards 4.0. Okay, so this is one one important topic called the sensor fusion. So how we can able to have different sensor fusion is going to be one of the important research which is going occurring here. As the humans, we are going to be having it is going to be getting the inspired from the human beings only. This sensor fusion is going to be done when you are going to be eating, listening music, romance, and everything. So you can able to do all the three things. Okay, so how we can able to incorporate these three things in a robots also we can able to see. Okay, so we can able to have the 5 senses at the same time. You can able to have integrate all the data from all the 5 sensors, and you can able to your brain can able to take the decision depending upon the different data of the sensors what will coming. Okay, so like that the sensor fusion also will be coming into one of the broad area. We will able to have the different types of sensors. We can able to have one camera will be fixed, one accelerometer will be fixed, and one audio sensor also will be fixed. We can able to get one video data is coming, and one vibration data is coming, and one noise data is coming. So all these three things we can able to fuse, and the data fusion, and from that particular data fusion we can able to get the information fusion, and from that particular information fusion you can able to make the decision making of the particular systems also we can able to do. That is how this particular sensor fusion is going to be occurring. So we are going to have the different 2 sensors will be there, and the same environment these 2 sensors are observing. So this is going to be some heat sensor like that you can able to take. Okay, I want to measure the temperature of this one. So either you can able to use a infrared camera you can able to use to measure this particular temperature measurement. At the same time you can able to use one thermocouple, okay, to measure this particular temperature, and you can able to use one optical microscope to measure this particular thing. And these are 3 sensor data can be fused, and that data can be used for the better enhancement also. You can able, that is going to be called the sensor fusion. Okay, so this is sensor fusion is mainly used in this particular autonomous vehicle systems what we have. Okay, so basically this particular autonomous vehicle systems will able to contain the 3 different types of sensors. What we're going to be having is global position sensor, LDR, the laser detection ranging sensor, cameras, ultrasonics, and central processing and radar sensors. What going to do? Okay, if you see these particular sensors mapping, you can able to get the sensor mapping like this. Okay, we are having the different sensors will able to have different mapping will be there, and you can able to see this mapping will be interfacing in different levels. Okay, so these mapping will be used for the different levels of automation you can able to have. So here, if you see the different levels of automation, level 0, level 1, level 2, level 3, level 4 automation. In each level, now if you want to know the driving of the car, you need 2 hands, 2 legs, eyes, brain is going to be required. So in each level, they are removing one. Okay, in this particular level 0, the hands and eyes are everything is there. In the level 1, he's not using leg. Okay, he's not using legs. Okay, that is we are going to be using automatic gear. The clutch gear system is going to be eliminated, and the cruise control also will be used there. In the cruise control, there is no need for you to give the acceleration, and gear change will not be there. So your legs will be free. Okay, so next we are going to be having is in the level 2, your hands also get free. So your legs and hands are get freed. Okay, and after that in the level 3, your eyes also get freed. The car will be able to take itself. Okay, and in level 4 and level 5, you can able to have your brain also free. The car will be able to take care everything what going to have. Okay, so people have reached up to this particular level 3 and level 4 trials has been successful in USA, but in this level 3 components, we are going to be having some different automatic car parking, driver assistance, like park whenever any particular collision resistance will be there. We can able to see this type of things also. You can able to see in your Indian cars also. You can able to see up to the level 3, but level 4 is not there. But your Google or Tesla has reached up to level 4. They are still going for the level 5. So this is going to be done by using this particular fusion of the sensor techniques what we're going to have. Okay, the fusion of sensor techniques, we are going to be getting the accuracy, resolution, reliability, safety, and redundancy is going to be coming. These are all some of the important things what we're going to be getting. So my example of this thing is you can able to take the picture of the satellite pictures also you can able to take. Okay, so the satellite can able to take different pictures, and we can able to predict which area is going to be green area, or which is area is going to be the soil area, or which area is going to be the different things also you can able to take that one. Okay, so similarly the global positioning also we can able to make by using this one. Okay, so some of the examples you can able to see in automobile collision evidence you can able to eliminate. This is the stereographic imaging is one imaging where we will have the 2 cameras will be kept to this particular the drones. So now we are going to be having the drones are going to be coming. These drones will able to capture the image in 2 different cameras, 3 different. One camera will able to capture one angle, and another camera will able to capture another angle, and this 3D image will be represented so that you can able to identify the height of the trees. Suppose in the forest, how much the trees are going to be height. Okay, so previously you are going to be getting the 2D image are going to be coming. 2D image are getting coming in the drones. So when you are going to be using the drone systems, you will able to get the true 2D image. Okay, so by using this particular stereographic imaging, you can able to get the 3D image. The depth also you can able to measure by using this particular the sensor fusion technique what we're going to be using. Okay, similarly for the military applications also, the sensor fusions are going to be mainly used for detection of any particular submariner. Any enemy submarine is going to be entering in your coastal things, that also you can able to detect by using this particular sensor fusion. Okay, so this sensor fusion can be done at the data level, feature level, or decision level also you can able to do. This is people are doing the lots of research. This is one example where I want to detect in the cutting machine. There is one fish cutting machine is there. I want to identify the different failures. Okay, so the different failures will be identified by using this particular the 3 different types of sensors what we're going to have. So we are going to be using either microscopes, cameras, accelerometers, and microphones are used, and these data is going to be identified by each fixed fusion storage will be done, and automatically you can able to get the time domain features or frequency domain or hybrid features are going to be extracted, and finally we can able to give to this particular neurophysiologic system, or the deep learning systems also now coming, and that will able to decide which type of fault is going to be occurring by using this particular fusion of this particular things. Okay, so this is one of the one of my PhD student has done this one, the predictive maintenance system for any particular machine learning system. So we are going to be doing we are going to give the predictive prediction of the machine. Okay, so the prediction of the machine we can able to do, and we have developed one digital twin of that particular milling machine. We have developed for that one. So he has made this particular machine tool, and we have the predictive maintenance is going to be done by using the deep learning algorithms, and that will be send it to this particular cloud-based system, and from that particular data analysis, you can able to get the alert what we're going to be coming. Okay, so similarly, this is another project which is going to be done by one of our MTech students, which he will able to detect the visionary, the legacy machines detection. We have made one digital twin of the legacy machines. What going to have the legacy machines, which is going to be contain the old machines, which will contain the old the knob, everything. So whatever the things, by using the camera, you can able to get the exact digital twin of this particular thing. Okay, so this is another thing is we can able to use the steel manufacturing. Now they are going for the IoT based things. Okay, so now the same thing I will conclude my lecture. Now the humans are hooked and machines are learning. Okay, this is what today's reality. So if you see this one, this is the graph what we're going to be coming. The present computers, or the thinking of the computers, is the brain of the rat. Okay, so that is the brain of the rat. Whatever the rat will able to think. So the computers now presently reaching 2023 is going to be exactly reaching the brain of the human thing, or they may go beyond that. That is going to be called as the singularity, what the people are predicting. Okay, so that will able to cause as the industry revolution 5. So where you and your robot and the cobots are coming. So now we are present next generation, we are going to be coming. The cobots are there, where humans and robots are combinedly working each other. Okay, so that is what things, and these are all some of the important things. The 3 A's, that is automation, analytics, and artificial intelligence. This is going to be the present trend, and these are 2, AI and IA, intelligent artificial intelligence and intelligent automation. And this is how the cobots, both human and machine, has to work together. And these are all 930 technologies which is going to be for the next the 10 decade. The next 10 decade, these are the 10 important technologies which you are going to be requiring. Okay, so with this I will just acknowledge to my PhD scholars. These are all some of the Indian and foreign collaborators. And this is the person who has done that predictive maintenance thing. And this is explained. This person has done yesterday, that is modeling and simulation. And these two people are working on. I am also working on the nanotechnology, nano lubricants. These two people are working on nano lubricants. And new person has came. He is most probably working on the sensor fusion is going to become. His photo is not there. Okay, so these are the two people who are working in my lab, and this is going to be just I want to stop here. If you have any doubts, you can chat, type in the chat for another 5 minutes. Otherwise, we will call a day. I think the speaker has came or not. We have to see. Okay, if you have any doubts.
Okay, participants, if you want one-to-one conversation, you can raise your hand. We will unmute you.
Yeah.
Okay, you can chat. You can type your questions in the chat box also.
kindly provide, okay, so that online material we can able to get, no problem. What about the life of human beings, then industrial evolution begins? Okay. So that you have to think. Now you have to increase your brain. Any other questions? Difference between sensor and transducer. Okay. So already you have asked last yesterday also. The transducers means they are mainly they are going to have some change of energy is going to be there. Okay. So whereas in this particular sensors, they are going to be having some phenomena like electrical or it may be of electrical sensor or mechanical sensor will be there. But in the transducer, if a change of state from one state, that mechanical to electrical signal changing, that will be then it is going to be called a transducer. Or you can able to take it as the signal conditioning plus sensor is going to be considered as a transducers. Okay. So any other questions? How can you identify forward and reverse angular position? Okay, so that suppose I have already shown you in that particular video that animation. Once again, I will explain that one if you not understand that one. Okay, so here if you take this particular system, okay, suppose here. If the system is going, this is going to be the system what we're going to be having. The two systems are there. So this is one disk, and this is going to be another disk. Okay. So this is going to be dark, and this is going to be the light is there. Okay. And next system is this is going to be dark, and this is going to be the light. Okay. So when this disk is going to be rotating in this particular manner, suppose we are going to start, this is going to be the point. Okay. So we are going to be getting this is 0 and 1 we are getting. Okay. When we are going to go this rotation, then what are getting 1 and 0. So when this particular disk is coming in this particular manner, it is going to be 1 0. Okay. It is going to be 1 1. So like that. Okay. If you are having the disk coatings are like that, so the starting will be 0 and 1. And if the disk is rotating in this direction, it will become 1 0. If the disk is rotating in this direction, it will become 1 1. Okay, or that is how. If you are getting this from this particular position, if you are getting this particular position or this particular position, you can able to tell the disk is rotating in these directions. Okay, so yeah. Any other questions? I think it is cleared your doubt. So any okay. So yeah, in this context, the sensor is a part of transducer. Yes, true. Okay, so just we will take if you no more questions. If you have any questions, you can able to ask me. If you have no more questions, we will take for 5 minutes break, and the second session we will start.
Dear participants, the feedback link is shared on our WhatsApp group. Similarly, is being shared on the chat also. Webex chat box, you can check now.